Moving on through the endocrine system, we have covered the hypothalamus, the pituitary gland, both the anterior and posterior pituitary gland, and the thyroid glands. We have covered the hormones that are secreted by these glands and the issues or the diseases that can be caused by an imbalance from these hormones. The next gland on our list is the parathyroid gland. The parathyroid gland secretes, you guessed it, parathyroid hormone. That's the hormone when we're talking about bone production that removes calcium from the bone. It stimulates the osteoclasts and it responds to increased blood calcium levels. I know we've seen this image a couple of times. You've got the rising blood calcium levels, which initiates or starts the thyroid gland to release calcitonin. Calcitonin stimulates the bone to lay down calcium into the bone or increase calcium salt deposits within the bone. That in turn decreases the amount of calcium that is in the blood. As you have falling calcium levels, your parathyroid hormone starts to work. Your parathyroid gland releases PTH. PTH then in turn starts the process of the osteoclasts to break down bone to increase those blood calcium levels. It is that opposites and that negative feedback loop. This particular one we've been seeing for a while. All right, your next gland is your adrenal glands. Your adrenal glands are your hats to your kidneys. There's two regions. You've got your cortex and you've got your medulla. The cortex lies on the outside, and there's three primary hormones within the cortex. So there's three layers within the cortex. The outer layer releases your mineral corticoids. Your middle layer is your glucocorticoids, and your inside of the cortex are your sex hormones. The adrenal medulla, which is the inside of your adrenal gland, is where your neural tissue lives. So let's look at this. You've got your adrenal gland, which is the hat on your kidney. Kidneys are up here, your hat, and then you've got the outer layer, and if we look at this part, you've got the outer layer, two layers. You've got your medulla, and you've got your cortex. Oh, excuse me. No, you've got your mineral corticosteroids, you've got your glucocorticosteroids, and your sex hormones that are released here, and then the inside of it is your medulla that has all of your neural tissue. So let's look at these hormones. Aldosterone is the main mineralocorticoid that we're going to talk about. It is in the outer adrenal cortex. It regulates the sodium and potassium ions in your blood. It is your electrolyte balance, which means it almost specifically targets the kidney. Nothing else. You then have your aldosterone that is stimulated by a reduction in the sodium ions or an increase in the potassium ions. It's what achieves that balance. You've got hormonal stimulation, or ACTH, and you've got renin and angiotensin 2 that are secreted in regard to a drop in blood pressure. It is inhibited by atrial natriuretic peptide, ANP. Tough word, not going to worry about it. ANP is produced by the heart when your blood pressure is too high. One of the reasons why you don't want your blood pressure too high for too long of a period of time, because it inhibits aldosterone production, which in turn throws off the electrolytes within the body and the blood. Here's an image of that. So you've got your direct stimulating effect, which is the balance of the sodium and potassium in your blood, whether it's a decrease in sodium or an increase in potassium. that will directly stimulate the adrenal cortex. You've got decrease in blood volume or blood pressure, which then stimulates the kidney. This is your indirect. The kidney releases renin, which in turn releases angiotensin II. And then you've got your hypothalamus that releases ACTH, directly affecting the adrenal cortex. And then lastly, you've got an increase in blood pressure, which leads to an increase in blood volume. The higher the pressure, the more volume there is. That releases ANP, which inhibits the work of the adrenal cortex. You don't necessarily want to inhibit the adrenal cortex because it will throw off your electrolytes and cause health issues. All right, so we've got the aldosterone. Let's move on to glucocorticoids. That's your cortisone and your cortisol. They are your stress, or they're your stress hormones. They're the ones that are going to resist the long-term stress of, say, this situation. They help to maintain normal cell metabolism, and they're produced by the middle layer of the adrenal cortex. They are anti-inflammatory, and they are released in response to an increased level of ACTH. ACTH being released from the anterior pituitary in response to increased blood pressure. All right. As we all know, increased blood pressure is something that is associated with long-term stress. Moving on, we've got our sex hormones. They are produced in the inner layer of the adrenal cortex, and they make small amounts. This is not large. You go through puberty, you have your big spikes of your hormones, androgens and estrogens, but as you move throughout life, it's only small amounts that are made. So they are your androgens and your estrogens, female and male sex hormones. Adrenal cortex disorders. You've got Addison's disease. Addison's disease results... Okay, so Addison's disease is basically your adrenal cortex shuts down. It's not releasing the hormones that it would normally release. This is muscle weakness. This is a decrease in immune response, burnout, and it changes the color of your skin. Addison's disease is also sometimes related to stress. It can be a stress disease or a stress response. You've got your hyperaldosteronism. Ugh, that's a horrible one to say. That is usually from a tumor, and a tumor that releases too much ACTH. It causes water and sodium to be retained, which seriously increases blood pressure and causes swelling within your system. All right, here's this image again of your different pathways. Adrenal cortex disorders, continuing on, you've got Cushing's syndrome. Cushing's syndrome is a tumor in your adrenal cortex. You have that big round face, moon face, or you've got a big hump, a fatty hump on your upper back. It is also known for high blood pressure, low blood sugar, and a weakening of the bones, which means it's easier for your bones to break. It also causes depression. You've got masculinization, which is a hypersecretion of male sex hormones, usually seen in the bearded lady. 100 years ago when you had P.T. Barnum going around with his oddities, well, the lady that had the full beard, she was dealing with masculinization due to hypersecretion of male sex hormones. Are you done? Stop. All right, starting again. Sorry for my dog. That was Elliot. He definitely wants to get his 2 cents worth in. He always does. We've done adrenal cortex, Okay, so let's move on to the adrenal medulla. The adrenal medulla is your short-term stress hormones, your epinephrine and your norepinephrine. These are the hormones that are going to get you away from that big bad bear that's going to chase you. Increases your heart rate, increases your blood pressure and your blood glucose levels in order to give you the energy and the strength to move away from danger. It also dilates your lungs to allow for greater oxygenation of your blood. So you've got your epinephrine and norepinephrine, which are in the adrenal medulla. The adrenal medulla is, once again, your neurological center for your adrenal glands. That is why, as we go back to here, epinephrine and norepinephrine are your fight or flight. That is a direct neural response to a stimulus. So let's take a look at stress real quick. This is a pretty good chart. Short-term stress response. When you've got that bear chasing you, you've got an increased heart rate, increased blood pressure, you've got an increase in blood glucose level, dilation of your lungs so that you can breathe and bring in enough air or enough oxygen to your muscles to get you away. It increases metabolism. Basically, it ramps up your entire body to get you out of danger. A lot of times, though, especially in situations like we're in right now, stress is not a short-term thing, and our body is not necessarily really good at adapting for long-term stress. So on the green side of this, it shows how long-term stress, how our bodies respond to long-term stress. You've got the releasing of hormones, you've got stress. Stress from the brain is prompting a releasing of hormones in the anterior pituitary. All right, those hormones are ACTH, which go through the blood, which stimulates the adrenal cortex. The adrenal cortex is going to stimulate your mineral corticoids and your glucocorticoids. That's going to increase sodium and water retention, which will in turn increase your blood volume and your blood pressure. Long-term blood pressure from stress, this is how it happens. The other side of it is glucocorticoids are going to break down glucose or break down proteins and fats to give you glucose to increase your energy levels. It increases blood sugar and suppresses your immune system. You've got your long-term stress. Your long-term stress starts in the brain and stimulates the anterior pituitary to release the ACTH. Okay, the ACTH then affects the adrenal cortex to release your mineral corticoids and your glucocorticoids. Same kind of thought process as what your short-term stress response does, only your short-term stress response is initiated by an actual neurological impulse, whereas your long-term stress response is stimulated by the release of a hormone from the pituitary gland, being the ACTH. The ACTH releases the mineralocorticoids, which retains sodium and water and increases your blood pressure. The other side of it is your glucocorticoids, converts protein and fats to sugar. Sugar will go into your bloodstream, increasing your bloodstream sugar levels, as well as decreasing your immune response. All right, now that we've seen how stress works, let's move on to your pancreas. Your pancreas is close to your stomach. It is both endocrine and exocrine, which means it does two different jobs. You've got your pancreatic islets that produce the hormones of insulin and glucagon. Insulin is produced by beta cells, glucagon alpha cells. These hormones work opposite each other to maintain sugar levels within your blood. So here's your inlets, and here's your exocrine cells. This is a better picture. So you've got capillaries, and you've got your alpha cells, which are the red ones. Okay. Your alpha cells are producing your glucagon. And then you've got your beta cells, which are the blue cells, and they're producing your insulin. Insulin is released when blood sugar levels are high, and it increases glucose uptake by cell bodies, which means insulin initiates the body to absorb more glucose into it. Glucagon is released when blood sugar levels are low, and it stimulates the liver to release glucose into the blood. So it's a pushing and pulling scenario. When glucose is high, insulin is released. When glucose is low, it releases glucagon to increase the glucose levels. Diabetes is the absence of insulin. So what you'll see is blood sugars spike up because there's no way for the body to deal with the other half of that pushing scenario. You've got the glucagon releasing glucose into the blood supply, but you don't have the insulin that's taking the glucose out of the blood supply. So what you'll see is polyuria, where there's 3 cardinal symptoms or signs of diabetes. Somebody's peeing all the time, polyuria. You've got somebody that's constantly thirsty, which is your polydipsia, and somebody that's constantly hungry, polyphagia. Because what's happening is you've got the inhibition of the uptake of water and minerals in the urine. So you're releasing more water from your body. That's your polyuria. Because you're releasing more water from your body, you're naturally going to be thirsty. It leads to dehydration. And then because your body is not taking in and processing the glucose the way it should be, you're constantly hungry. So you're eating more to try and make up for the lack of cellular energy forming. This is a big one. Okay, so you've got your balance levels. You've got your increased blood glucose here, okay, elevates your blood sugar, which initiates the pancreas to release insulin. With the insulin being released, it causes the liver to store up or to absorb the glucose from the blood, but as well, it also spurs the uptake of glucose into most of your body cells. As the glucose levels in the blood fall, that's going to stimulate the pancreas to release glucagon. Glucagon is released and prompts the liver to start releasing that stored up glucose into the bloodstream to create that balance again. Okay, pineal gland. Pineal gland is in the 3rd ventricle of the brain, and it's your sleep cycles, your melatonin. Most people have heard of melatonin, taking a melatonin supplement when you are not sleeping too well. Well, it occurs, or it's secreted by the pineal gland, and you are taking a hormone. It is a hormone, much like any other hormone, that testosterone, estrogen, epinephrine, it can impact your biological rhythm. That's why when you're taking a melatonin, you should not take a melatonin in the middle of the day. You should not take melatonin when it is sunny out. It's something that you should take maybe 10, 15 minutes before you go to bed, and then turn your lights out. Because if you take it when the sun is up and you're still working, it's going to seriously mess with your biological sleep cycles. The other thing that they suspect that it does is help in fertility. You have your thymus gland that is located just posterior to your sternum. You see it it's most obvious in infants and children. And it's associated with your immune system and white blood cells specifically. Okay, so we've done everything down. Now it's time to go into the gonads. Your gonads, you've got your ovaries, produce your eggs in women, and there's two hormones or two steroids that they release, your estrogen and your progesterone. In your testes, which produce your sperm, they produce androgens such as your testosterone. So testes produce testosterone, ovaries produce estrogen and progesterone. Estrogens, they stimulate your female characteristics. Estrogen is what prompts puberty. So once puberty is initiated through an increased production of progesterone and estrogen, you begin to see breast development and you start to see a regulation of a girl's menstrual cycle. The other part of it is estrogen has another aspect where it initiates the maturation of the female reproductive organs, but as well the maturation of the eggs within those organs. Progesterone also helps to regulate the menstrual cycle, helps with implantation of an embryo. So when an embryo implants in the uterus after fertilization, you will see a slight spike of progesterone. And then after, it helps with lactation. Okay, testosterone. It is the most important male. It produces or spurs the secondary sex characteristics. So you see a spike of testosterone in boys as they go through puberty. And you have to have testosterone in order for the sperm to develop within the testes and then allow for the continuation or the reproduction of our race.